So if you're trying to figure out what chapters we're working on when we're doing the homework, easiest way to do that so let's say you're working on the homework for this week. Which is right there. Actually, let's go back to the homework one. I want to point out something. This is past due now, so you notice when I click on it, it says review and practice. That's if I just want to go back and look it over to study for a test. Or it says improve score. That's where it's going to tell you, hey, if you do this, it's going to give you a penalty for being late. Don't worry about that on the first one. That's the one you want to click if you need to go back and do it, is improve score. It's going to give you the warning, yeah, late penalty, too bad. Don't worry about it. So if I'm doing one of these questions, again, this is assignment 1, not assignment 2. If I look up here, this is telling me that's chapter 3 out of the book. Section 2 of chapter 3. So you can always, off the homework, figure out what chapter we're in. So right now, that was last week's. So this week's material, you see this one is from chapter 5. So you're right. This is scattered through chapters 4 and 5. I was wrong. I was thinking the old version. I forget this one's now numbered starting on chapter 2, not chapter 1.
And we go where for this?
This quiz. In my math lab, you see it says quizzes and tests. Actually, if you're at the home, in the dashboard here, the quiz should now show up here as due February 2nd. You can just click on it there to do it as well. They'll give you the option. Remember, once you start, you get 2 attempts. Once you start it, you got to finish it.
And that's pretty much what we covered last.
That's what we covered last week. Yep.
So is the second attempt the same questions as the first one?
Same questions, different numbers. It'll automatically change the numbers for you. And once you're done, you can go back and look through and see what you got wrong. The biggest thing is when you're looking at them, after you've completed them, you might look at it and it'll show the right answer. And you think, well, I answered it correctly. Well, what you got to do is you got to point at the thing and click on it, and it'll tell you what you answered. So the default in my math lab is to show you the right answer when you go back and look them over, not what you answered. So I get that every semester of, well, the right answer is there. I don't know what's wrong. Well, it is showing you the right answer. Take the mouse and click on the right answer, and it'll show you what you put in. Okay, so where are we going with all this? Well, there's another type of equation we need to be able to solve, and that looks like this. This is a simple proportion. Many of you have probably seen a simple proportion before. Next week, when we talk about percents, we're going to do a lot with proportions. To solve a proportion, we cross multiply. 5 times 21 is 105. X times 35 is 35x. Those cross products have to be equal to each other. So the 105 has to equal 35x. So we can divide. Yeah, you could have reduced the 21 over 35. I was just being lazy in how I wrote the fraction. So yeah, you could reduce that. So you divide out the 35, x is equal to 105 divided by 35 is 3. We might have 3/7 equals x plus 2 over 28. This one's not quite as simple to solve, but we're still going to cross multiply. 3 times 28, which equals 84. Cross multiply this way, it's 7 times, now I have to put it in parentheses, x plus 2. Well, 7 times x is 7x. 7 times 2, positive 14. So 7x plus 14 has to equal the 84. And now we can solve. What do we have to do? Subtract 14. So 7x equals 70. And then divide by 7. X equals 10. Okay, so our next step is to start looking at word problems. I know a lot of people cringe when they hear the word problem. Right up there with fractions, word problems is one of the most hated concepts in math. Unfortunately, business math, in the business world, life is a word problem. Your boss is not going to come up to you very often and say, 5x minus 2 equals 33, find x quickly. Not going to happen. You're going to have a situation where you have to be able to pick out the information. You either use the correct formula or create an equation for it and then solve. The problem with word problems, especially starting out with word problems, is usually the first word problems you do are so simple you don't need to write an equation. It's almost confusing, almost more difficult because you already know how to find the answer. You don't need to write the equation. I'm going to ask you over the next 10 minutes or so, be patient with me. Even though you know how to obviously solve these questions without an equation, it's what we need to build up to the ones where you really can't solve without being able to put them into some form of an equation. So we're going to start out with a simple one. It is Pete's taxes are 1/4 of his gross pay. Pete pays $1,123 in taxes. Excuse me. What is his gross pay? Most of you are probably looking at this right now and saying, yeah, I'm just going to take the 1123 times 4. I've got the answer. And you are correct. But let's step back and write an equation for this situation. The first line here describes what the equation is going to look like. Pete's taxes are 1/4 of his gross pay. So we're going to let T represent his taxes. I'm going to change that T just a little bit so it actually looks like not like a plus sign. We're going to use a script T like that. T for taxes. G for gross pay. So his taxes equal, how do we do 1/4 of gross pay? Just 1/4 times gross. 1/4 times G. You could have done G divided by 4 as well. So we have an equation. Any questions on where that equation came from? Okay. Now we plug in what information we have. Pete pays $1,123 in taxes. What does that go in for? T or G? T. That is T. Now to solve this equation, we would, that's 1/4 times G. So to get rid of it, we divide by 1/4. 1,123 divided by 1/4 is 492. Or 4,492 equals G. His gross pay is 4,492. 1,123 divided by 1/4 and 1,123 times 4/1. So yeah, it's times 4. Excuse me. Let's say that you sell items at $23 each for a total of $3,381. How many items did you sell? So here's one where the problem doesn't necessarily spell out what the equation has to be. The equation comes from our knowledge of how things work. And this happens quite often. We end up with the equation is a known formula, or it's just a common sense relationship. Here, your total, and I'm going to just write it out in words, has to equal your price per item times your number sold. Does that make sense? Total dollars is price per item times the number you sell. So which of those do we know? Do we know the total? Yes, $33.81. Do we know the price per item? $23 each. Well, we better not know the number sold, or this isn't a very interesting problem, is it? So the number sold is what we're looking for. How many items are sold? So I'm going to put in a variable for that. What letter do you want to use for the variable?
N.
N. Okay, so 23 times N. Now, some people would say use S for sold. I'm going to caution against using S as a variable. Let me show you why. In my sloppy handwriting, that's a 5 usually, but that sometimes is a 5, or is it an S? Okay? Just a caution. You will see me sometimes very seriously exaggerating the S's like that to make sure, but even then, if I get a little kink in the corner, it might look like a 5. So now how do we solve this equation? What's that?
Just a cursive S does the trick.
A cursive S would do the trick. It's just, I just avoid it so I don't have to deal with it. So what do we do here?
Not a problem. Divide by 23.
Divide by 23. Good. So 23 is gone there. That's N. 3381 divided by 23 is 147. Perfect. So we have to sell 147 items. Let's say Pat travels 312 miles in 6 hours. How far will Pat travel in 8 hours? Now, before you jump in and try to write an equation here, I'm going to tell you right up front, this problem is very different from the others. This is one where there's actually two relationships here. We're talking about travel and speed. Your speed here is equal to the distance traveled divided by the time, right? We are assuming that Pat keeps traveling at the same speed. Does that make sense? So the speed he or she has been traveling is 312 miles over 6 hours. Assuming that Pat keeps traveling at that speed, this ratio here has to be the same as this one. So we know the 8 hours. One of the properties of a proportion or equal ratios is the units have to match up. So hours are on bottom here. Hours are going to be on bottom over here. So the 8 hours goes there. So this is going to be our x. So we'll cross multiply. 312 times 8 is 2,496. 6 times x is 6x. So 6x has to equal 2,496. We solve by divide by 6. So x equals 416 miles. In 8 hours, Pat will drive 416 miles. Let's make these a little more complex. Let's say that Chris sells 3 times as many cars as Sam. In a week where they sell a total of 52 cars, how many did each sell? So here we have 2 things that we are looking at. Looking at the, the number that Chris sold and the number that Sam sold. I don't want to do 2 variables. So what I have to do is look to see if there's a relationship between these 2 items. Is there a relationship between the number Chris sells and the number Sam sells? And there is. Chris sells 3 times as many as Sam. So now one of these is referenced off of the other. Chris's sales reference the number of sales that Sam makes. So we're going to let Sam's sales be X. We can make it S, N, P, whatever variable you want to use. We're going to let it be X. If Sam sells X cars, how many does Chris have to sell? 3 times. So 3X. And we know they sold a total of 52. So Chris's sales, 3X, plus Sam's sales, which are X, have to equal 52. Now, I will catch at least one of you doing this on a test. What is 3x plus x?
4x.
4x. I will catch a lot of people saying, oh, 3x plus x is 3x squared. It's not. Think of this as 1x, like 1 inch. Sometimes you just call it an inch. 3 plus 1 is 4, so that is 4x equals 52. And now we solve that by doing what? By 4. So x equals 13. Are we done? Say no. No. Why not? Yeah, we have to answer the question. The question's asking how many did each sell? Well, x is 13. That's how many Sam sold. Chris is 3x. That's 3 times 13, which is 39. That's how many Chris sold. Now we can double check. Is 39 plus 13 52?
Yeah.
Yep. Is 39 3 times 13? Yes. So it fits the problem. You can always go back and double check to make sure it fits in the problem. This is an example of a typical type of problem we run into. Number A plus number B has to add up to be a total. There's another typical type of problem we run into. Number A minus number B equals a difference. So let's look at an example of that. Let's say that Pat sells 4 times. We'll stick with car sales for the fun of it. As many cars. This time of night, I'm not horribly creative, if you can't tell. 4 times as many cars as Stacy. If Pat sells 48 more cars than Stacy, how many did each sell? So once again, we have number Pat sells, number Stacy sells. Once again, we're going to look for a relationship between the two of them. So without me doing any prompting questions, which one do we want to let be X? Pat's number of sales or Stacy's number of sales? Stacy's. Because Pat's sales reference Stacy's. So what's Pat's going to be?
4x.
Perfect, 4x. Because Pat sells 4 times as many as Stacy. Now in the last one, we added the two together. In this one, what do we have to do? Subtract them, yes. Pat sells 48 more. In other words, Pat minus Stacy equals 48. Or you could say Pat equals Stacy plus 48. That's another way you can do it. So Pat is 4x minus Stacy, which is x, equals 48. Again, we treat that as a 1x, so it's minus a 1x. What's 4x minus 1x?
3x.
So 3x equals 48. And then
X equals 16.
yes, we divide by 3.
Yes.
X equals 16. All done?
No.
No, what do you got to do? Well, x equals 16. That's Stacy's sales. Pat is 4 times 16, or 64. That's Pat's sales. What do you think?
Cool.
Better than a sharp stick in the eye so far?
Yep.
Good. Let's say Steve sells 5 more cars than Tom. They sell a total of 43 cars. I'm not going to write it out, but again, how many did each sell? So we got the number Steve sells, number Tom sells. Which one's going to be X? Tom. What's Steve going to be? X plus 5. 5 more than Tom. 5 more than implies you're adding 5 to it. Now, are these two adding up to a total, subtracting to make a difference, or something else? They are adding to make a total. Steve's, the X plus 5, plus Tom's, which is the X, adds up to a total of 43. So what can we combine here? Yes. We got a 1x and a 1x make
2x.
2x. So it's 2x plus 5 equals 43. And then
Subtract 5 from both sides.
subtract 5. So 2x equals 38. And then divide by 2, x equals 19. And then, so we've got Tom is x is 19, that's Tom's. Steve is 19 plus 5, which is 24. That's Steve. Any questions? Got to make it worse one more time. Let's go back to Pat. Let's see. Pat sells t-shirts for $8 each and hats for $4 each. Pat sells 3 times as many t-shirts as hats. If total sales are, let's see here. $448 for the day. How many of each did Pat sell? There's an extra layer on this problem. So now we're not looking at people. We are looking at t-shirts and hats. And once again, it's the number sold. But notice I kind of left it a little blank here because we're going to have to fill in some other information. So the number sold. What's the relationship there?
3 times as many shirts and hats.
So which one's going to be X?
The hats.
The hats are going to be X. T-shirts are going to be
3x.
3X. 3 times as many t-shirts as hats. But we don't know the total number sold. We know the total dollar amount. So we need to find the total dollars. To find the total dollars for each, you take the number sold times the price. So for t-shirts, we sold 3X times how much each?
$8.
$8. 3X times 8 is 24X. For hats, we sold X of them times how much each? $4 each. X times 4 is 4X. Those two have to add up to the total sales of $448. So 24X plus 4X equals 448. Now what? 24X and 4X make? 24 and 4 make 28, so 28X equals 448. And then we divide by 28. So X equals
16.
16. Good. Now we have to make sure we answer the question. X is the number of hats. So 16 is the number of hats. 3X is the number of t-shirts. 3 times 16 is 48 is the number of t-shirts. We were asked how many of each did Pat sell, so that is what we're looking for. A variation of that problem might be asking how much money did Pat make or did bring in from each. Then I would have to go through here and do, okay, 24 times 16 is the dollar amount from t-shirts. 4 times 16 is the $64 from hats. We're going to do 2 more problems and then I'll let you guys go, I promise. This problem should be looking a little bit familiar so far. So Pat sells 64 items for a total of $448. Once again, how many of each did Pat sell? So we're going to start setting this up the same way again. T-shirts and hats. The problem is, how do we define our variable? In this case, it does not matter which one I let be X. Doesn't matter at all. I'm going to be a little bit easier to solve if I let a certain one be X, but it really doesn't matter. So pick one, t-shirts or hats. Which one do you want me to let be X?
T-shirts.
T-shirts, okay. So would X be the number of t-shirts sold? So if X is the number of t-shirts sold, how do we know how many hats were sold? Well, we could put in Y, but we can't work with 2 variables. So we've got to figure out a way of defining that in terms of X. Now, if we were in a more advanced algebra class, we would do a system of equations, X and Y, and we'd solve it. But I don't hate you guys that much. Not yet. No. We won't get into systems of equations here. But we do know there's 64 total items. So let's just put the problem aside. If we know there's 64 total items, if I were to tell you that 10 of them were t-shirts, how many hats would there be?
54.
54. How'd you get 54? Did the 64 minus 10, right? So the number of hats sold is 64 minus the number of t-shirts sold. So 64 minus X. A little bit different than anything we've seen so far. Any questions there on where those come from?
If we would have done t-shirts, could we have done hats as X squared?
Nope, that won't work. You can only deal with a single variable. Remember, an X, X squared are different variables. So now we've got to find the dollar amount from each. The dollar amount from each is the number sold times the price. So X times 8 is the dollars from t-shirts. That's 8X. 64 minus X is the number for hats times 4. Now this looks a little bit backwards, but we can still go ahead and do it the same as others. 4 times 64 is 256. Now be careful here. This is 4 times a negative X.
Minus 4. Negative 4.
Negative 4X or minus 4X. So these two things add up to the $448. So 8X plus 256 minus 4X equals $448. This one's a little tougher. you understand where the 64 minus x comes from?
Yeah.
Okay. Well, then all I did is we took the amount, the number sold times the dollar amount each. So x times $8 each is 8x is the dollars for the t-shirts. Then we have 64 minus x hats times $4 each. So that's the dollar amount for the hats. So we're just adding the two dollar amounts together to get the total dollar amount. So now, what can we combine here? 8x and negative 4x make 4x. Plus 256 is 448. And then subtract the 256. 4x equals 192, correct? Is that right? Yeah, that's right. And then divide by 4. X equals 48, correct?
Yep.
So now we got to go back and answer the question. 48, number of t-shirts. 64 minus x becomes 64 minus 48 is 16, number of hats. Notice this is the exact same problem we did before, just a different way of wording it. Sir. Here. So we got 16 and 48 up here as well. It was just we did one was times a certain amount times the other rather than adding up to a certain total. Okay. One more problem, and then I'll stop the punishment for the night, I promise. A lot of times we deal with ones where there is a set formula, like I said. You know, the speed being distance divided by your time taken. Well, one of the formulas that we're going to deal with a lot before we are done here is the simple interest formula. I equals P times R times T. Principal times rate times time. So if Sam pays, let's see here. You ever have one of those days where the brain just shuts down for the night? $40 interest for the month. At a rate of 6%. How much is the principal? On Sam's loan. So, I is the dollar amount of interest. P is principal. That is the starting amount. R is rate. That is a percent as a decimal. T is time in years. So I know I, that's the $40. Do I know P? No, that's what I'm being asked to find. Do I know R? 6%, but it's the percent is a decimal. So I'm going to tell you 6% is a decimal is 0.06. Do I know the time? A month. Now it says the time is always given in years, so a month is 1/12 of a year. So now, just like any other equation, before I solve this, I have to combine anything that I can on one side or the other. So over here on the right side, I have 0.06 times 1/12. If you have a fraction calculator, it's easier to do. On mine, I can just do 0.06 times 1 divided by 12, which will give me 0.005. So I have P times 0.005. So 40 equals P times 0.005. How do I solve that? Divide by 0.005 on both sides. Correct. So over there, that's P. 40 divided by 0.005. Now I'm going to show you a neat little trick on your calculators. I did 40 divided by 0.005 was my last answer. So I hit second. And then my negative key, you see it says ANS above it. That's saying that's the previous answer. So you take 40 divided by the previous answer. $8,000 is my principal. So the principal on Sam's loan is $8,000. Any questions? Have you had enough for one night? Remember, there is a new quiz. That is quiz 1. It is due tomorrow. That is Thursday at 11:59 p.m. There is a new homework. Homework 2 due for next week. There are a few of you that still need to do homework 1, so I'd recommend you do homework 1 before you do the quiz. If you run out of time tomorrow, let me know. I can extend the quiz a little bit for you as well if I have to. The homework you can keep working past the due date. It's just going to give you the warning about being penalized. The quiz will actually shut down at 11:59 p.m. tomorrow night. So give yourself enough time to do the quiz before the deadline. Have a good night.